Hi, everyone. So I'm Shreyas Derashri. I lead the compute product management at Imagination. So compute includes the RISC-V CPU as well as AI compute running on both CPU and GPU. So before I kind of dive into what Imagination has been doing on integrated systems, let me first focus your attention towards what Apple has been able to achieve by putting an integrated system together. So if you look at the Apple M2 silicon, they've been able to achieve much higher performance at a much lower power envelope. And that's coming largely from the way they have integrated the system memory together. So one of the challenges we face as we go down lower nodes is that the memory is not scaling in the same way as logic. So that means utilization of memory at lower nodes becomes much more important. So as as we develop these integrated systems, it's essential to have a view of having efficient memory management across these integrated systems. Optimized compute platforms with CPU, GPUs, and AI also deliver optimizations around bandwidth and system data congestion. And that's again proven by Apple in their silicon. The other thing I also believe is through system level design, we also enable strong ecosystem enablement, which of course is beneficial for RISC-V's ultimate adoption. So how much of this is actually impacting in silicon today? And again, the answer comes from the M2 silicon from Apple. So if you look at the silicon sort of percentage, putting CPU, GPU, AI, and the system level cache, integrated cache that Apple has put together, it's a significant 50% of your total SoC that is occupied by a CPU or GPU or the AI solution that you deliver in that. So it accounts for more than half of your silicon. So getting that optimized and performant is really, really important. So we all know the benefits of CPU in an integrated system. So I wanted to focus a bit more on the GPUs, particularly starting with graphics, one of the functions that the GPU does. So if we look at the total semiconductor TAM, and we remove the RF parts, the memory parts, and some of the interconnects, GPU for its graphics use case is attached to about 44% of the total semiconductor TAM. So around 44% of the silicon today has got a GPU in there. The second thing, which is not very obvious, but I think is important to point out, is RISC-V will not be able to disrupt the Android market with a credible and a capable GPU. Now, Android, as it is an OS which is very focused on UI, UX, and having a credible GPU is very important for having RISC-V adopted in this market. We, of course, all know that GPUs nowadays are being used a lot in AI as well. And fundamentally, what I'm going to state here today is GPU is the platform for running AI. So CPU on its own does not deliver the level of performance density or compute density that is needed. On the other hand, GPU programming model has been well established, whether it's looking at NVIDIA and CUDA, or very recently looking at SYCL and UXL. So that direct programming model for a GPU has been pretty well established in the AI space. The other thing that goes against fundamentally a very custom accelerator approach is that the algorithms in the AI space are changing at a very, very fast pace. And what you really need is a flexible but yet capable platform, especially having a direct programming model to deliver that AI solution through a GPU. Again, similarly, array-like approaches. Again, personally, I feel they don't deliver that direct programming model and struggle to have that flexibility and programmability in general. So having looked at GPUs and having understood what CPUs are capable of, where do you actually get an integrated system? And that's where imagination comes in. So imagination is your one-stop solution for embedded compute, particularly embedded compute on the edge. So we have GPUs and CPUs in our portfolio, and we deliver AI capabilities through our GPUs and CPU products in the portfolio. So I believe a number of you would be well known of imagination, but just to recap, so imagination has been a premium provider of graphics IP in the market. In the graphics space, imagination is the #1 GPU by volume in automotive and in the mobile segment. Cumulatively, imagination has delivered over 13 billion devices and products in the market. It's a very technology-driven company. We are driving innovation in the space, and that can be seen through the number of patents that imagination has, over 3,300 patents, and a large number of the 700 plus team involved in R&D processes. We cater to a large number of market segments from automotive, mobile, consumer IoT, and data center, and we focus on all these markets. A quick look at imagination's product portfolio. So largely, our products portfolio is divided into two main product categories: the GPUs and the CPUs, which we recently started to develop, RISC-V based CPUs. So starting from your left, we have the efficient GPUs, XE-XM family of GPUs, which are targeted for performance efficient applications, low-cost applications, particularly in the consumer and IoT space. Then we have our XT range of GPUs, which are high-performance GPUs, which includes technologies like ray tracing, which are targeted for high-end premium mobile and some of the high-end automotive use cases. Then we have our XT range, which is supporting DirectX and ultra-high performance, mainly for a PC data center type of applications. And all of these GPUs are also available in automotive flavors, which we term as XS product family, which are GPUs which have functional safety capabilities built in for functional safety critical applications. That's been the main product portfolio for imagination for over 3 decades. Recently, in the last 3.5 years, we started to build RISC-V based CPUs. We launched our RISC-V based real-time CPU last year. It's been licensed a couple of times. It's seeing silicon now. This year, we announced our performance dense in-order class of CPUs, and I'll be talking a bit more about them. And now we are starting to work on high-end out-of-order CPUs as well. All the CPUs have got functional safety capable variants available for the automotive applications. And the way we look at AI is we look at enabling AI applications through CPUs and GPUs that we deliver. So I started by talking about the integrated system. And here you'll see we don't only focus on individual IPs to make them performant. What we look at making the IPs work together and deliver performance through an integrated approach. We build softwares and libraries across our products that deliver high performance and higher performance densities in various applications. In addition to an integrated system, imagination also delivers a suite of tools, profilers, debuggers, and trace capabilities for both our product lines. And all our products are built around functional safety and security in mind. We've had a number of years of understanding of the automotive market, and safety and security are vital to these two markets. So having given you an overview about imagination and what I believe you can achieve through an integrated system, I wanted to focus on an imagination-based integrated compute system solution targeted at consumer and IoT market. So first, having a look at the trends within the consumer and IoT market. If you look at your right-hand side, this is the report by SHT Group, which you've probably widely seen. It's been predicted that by the end of the decade, around 16 billion plus devices will have a RISC-V CPU, of which about 8.4 billion would be coming from the consumer and IoT space. So it's a critical area that is growing at a 40% higher CAGR. And one of the key things required in this market is a capable GPU and a capable CPU. So there has been, if you look at on the left-hand side, the key things driving this market are the extensive use of AI and the extensive deployment of sensors in this market. So the GPUs and the CPUs need to be much higher performant. There's, of course, an increasing complexity of user experience, which is driving the need of much higher performant graphics, much efficient as well. And one of the underlying trends in this industry is silicon cost and efficiency, which is critical in making successful products in this consumer and IoT space. So for this market, earlier this year, we launched the APXM 6200 CPU. It's imagination's first application processor. It's a 64-bit multi-core capable CPU with vector. So it definitely delivers the performance needed for the AI applications. But it's a classical application processor, which delivers both ecosystem support, security support, safety, etc. To our end customers. So when we launched this product, we focused on two big pillars: performance and trust. So performance coming from the performance density of the CPU, performance coming from the integrated system approach that we have, integrating CPU and GPU, together with software tools and security, and trust coming from being a trusted provider of IB for over 3 decades, trust coming from ease of migration from ARM-based designs, which is what the industry is needing right now. Trust also comes from compliance to RISC-V profiles. So our CPUs are compliant to RISC-V RVA profile, vector crypto. And trust comes from having a very strong, stable security system. So the security, which is widely accepted in the market today, is TrustZone. So we have provided an easy migration from an existing TrustZone-based design to a RISC-V-based design. Looking at performance from the APXM 6200, so APXM on its own is very small, largely coming from the RISC-V benefits that we have. APXM is about 20–25% smaller than an A53, which is ARM's most successful application core till date. It's about 40% smaller than an A55 and about a third of an A510. So that immediately gives you a cost advantage as you use an APXM 6200 in place of an ARM A53 or A55. But we've also been able to deliver a higher performance in this CPU. So just by looking at the spec-in numbers, APXM 6200 is about 65% more performant than a Cortex A53. But if you combine the small core and you look at higher performance, what you really get out is performance density. So that's the real advantage of this CPU. You are able to extract 2.5 times more performance density than a comparable ARM A53 product. The second part of this integrated system is the Imagination GPU. GPU, of course, we've been developing and delivering GPUs for a number of years now. So we have a range of GPU products that can go from the AXE116M, so a single pixel per clock, ultra small, very efficient CPU, to a 4-pixel 128 flop IMGC XM CPU. These are all our XE-XM class of CPUs, which are targeted for performance efficient, power efficient designs. So ultra low memory footprint and small bandwidth. In addition to that, we of course have industry's leading HDR lossy and lossless compression, which again saves the bandwidth in the system. And there's a range of GPUs available for all the use cases to cover in the consumer and IoT space. I think one thing that I mentioned earlier is Android support. We've been delivering products with Android support for a couple of generations now. And that experience, that proven experience of delivering Android support is coming through on our GPUs, but it also extends on our CPUs as well. And lastly, looking at that integrated solution. So when we put that APXM 6200 alongside our GPUs, we are able to extract up to 2x more performance out of the system. So we have an increased bus utilization and a reduction in memory traffic in the solution. And this is because we understand our GPUs, we understand the drivers that run on the CPU. We are able to develop the memory architecture of the cache architecture of the CPU so that we can efficiently integrate the two IPs together and deliver much more performance in the system. So this is my last slide. So all of that which I described is actually available to be seen here in the summit. So please do come to our booth B5 just around the corner, where you can actually see APXM 6200 working alongside our BXE232 GPU and actually running graphics on an FPGA. So a live demo on our booth is available. Thank you.